Here are the notes for Integrated 2 3.2.1. If we take a look at this, today on this Ed puzzle is going to be mostly some vocabulary, but then there's also going to be a GeoGebra video that you need to watch that should help you out with today's assignment. So slope triangle itself, going back to kind of Integrated 1 stuff that you did previously. We know that a slope triangle is used when we're first introduced to the idea of slope. So if we wanted to take a look at a very basic example of this, we would have a small coordinate plane, and then we would have the graph of some line on there. In order to use a slope triangle, what we would do is we'd identify 2 points on this line, and then we would create a slope triangle between the two of them. Now, what you can do, remember that slope is rise, so the vertical movement, over run, the horizontal movement. I typically like my triangle to look like it's going above the line, but you don't always see them like that. So you take a look down, we have our triangle oriented in a different way on the next example. So your slope triangle itself would be the rise, so the purple movement, over the run to get you from one point to the other. So just remember that the rise is the vertical portion and the run is the horizontal portion. And you do see that we create a triangle out of it using the 2 points that are connected on the line themselves, and then the triangle that we use, or the vertical movement and then the horizontal movement. As a reminder, slope is the rise over the run, or the vertical change compared to the horizontal change. So if we take a look at the next part down here, we're looking at this whole delta notation. Should look familiar. So delta, that means change in. So just as a reminder. So this means the change in. So we talk about the change in y compared to the change in x. Slope can be written a whole bunch of different ways. So we've got delta y over delta x. You can also refer to this as rise over run. And then you might actually remember the formula as well, which is the difference in y's, that's the change in y's, over the difference in x's. It's also the change in x's. We also call this m. All right, so if we want to take a look at the picture that we have down at the bottom, a little bit of review on slope. Remember, it is the rise portion first. So I typically, not all the time, but typically like to go from left to right. So I would find the leftmost point that's identified on this line, which I just identified as purple, moving to the rightmost point that's identified on the line, which is green. You want to think about the rise from the purple to the green. So I'm actually going to draw the triangle a little bit differently. I am going to go up from the purple. That rise, it is a positive rise, so it's a positive number, and then I count the boxes. That's 3. Then I would do the run over to the green. Notice that that is to the right, so it's positive, and it is 2 units. So the slope for this is going to be the rise, or the change in y, over the run, which is the change in x. Now we know that a positive divided by a positive is just a positive. So tiny bit of review on that. All right, some vocabulary here. Angle notation. So when we talk about angles, we typically use Greek letters. Well, Greek letters are just like a letter in the alphabet. So typically we would use X's and Y's and Z's, A's and B's, a whole bunch of different letters. You guys know that. But we also start using Greek letters specifically when we're talking about an angle. Probably the most popular one is theta. So there's theta. If you're drawing theta, it looks like an O or a 0, and then pick up where you left off, and there's like a little tail at the top, so it's like a little swish. So that's going to be our theta. Not quite as popular, but you definitely see them being used is alpha. And if you're drawing alpha, alpha looks like a little fish. You may have actually seen it on some bumper stickers, actually. Then if we take a look at the next one, this is beta. So beta, again, just Greek letters. So what it looks like to me is a capital B with a tail on it. So that's one way to do it. Or you can kind of slant your B sideways and then just put a little tail on it. So that's beta, just some letters. Okay, a slope angle. This is really what we're going to be building up to today. So slope angle specifically. We have it written like a slope triangle. What you and I are going to do, and this is where GeoGebra comes in, we are going to try to create on GeoGebra this line. So I'm going to identify it in blue. We're going to try to create that line. Then, so using the idea of slope, so let's say hypothetically speaking, so for example, that this rise is 5 and this run is 3. I know then that the slope of the blue line is going to be 5/3. So I know that the slope is 5/3. Now what I'm going to try to do is I'm going to try to create the most basic equation I can think of, that is the equation of a line that has a slope of 5/3. So I'm going to do y equals 5/3 x. Now if you wanted to put a plus number here, the most basic one is 0. So basically when I graph this using GeoGebra, I am going to graph an equation of a line that goes through the origin, that's the 0 part, with a slope of 5/3. Now I do want to create the other line. When we're using GeoGebra, we need to make sure that we have a line that it can snap to. So with that, I'm going to snap to the bottom of this triangle. So this purple line that I'm putting in. That purple line that we are going to be using, again, we want it to be right at the origin. So if I put my x and my y axes in here, so that would be my y axis, that would be my x axis. The purple line itself is a horizontal line, so it's going to be y equals, and it is going to be no distance away from the axis, so it's going to be at y equals 0. So when I use GeoGebra, which will be the next video that you should watch, I am going to enter y equals 5/3 x plus 0, or just y equals 5/3 x, and then I'm going to enter y equals 0, just so I have those two lines to kind of snap to be able to create my angle. And that's it. What covers it for this part of the video.